Welcome to this short introduction about a common major gap in satellite-based measurements on water quality. Quality and intercomparability standards. Satellite-based measurements increasingly contribute to fill data gaps for industries and agencies in various aquatic sectors. As a company, the major part of our revenues is generated nowadays from data and software services providing such data to actual users and decision makers worldwide. Satellites with the underlying data analytics and services can significantly further grow as accepted data source if these are recognized as accepted new measurement device with their own standard. So if users understand to formulate their demand in relation to available quality standards. That's common practice, of course, for all established measurement technologies, but not yet for satellite-based measurements. Nowadays, we have already an excellent situation with an increasing availability of satellite-based measurements from different data providers, with a source of actual and historical satellite records, daily growing a variety of different sensors between 1 meter and 1 kilometer resolution and daily coverages, a variety of algorithms, a variety of processed data sets, on-the-fly processing capabilities. We have portals, providers, and more market fit-for-purpose data services. From the user perspective, there is a range of mandatory requirements, and the most relevant is, of course, data quality, with all parameters related to their sensitivity, independency, consistency over time, spatial, temporal resolution. After this, we have user-friendly and customized access, which is relevant, and of course the hope that the quality further improves over time. For the satellite-derived measurements, we have the situation that these are very prone to errors through various environmental impacts. That means quality assurance mechanisms really matter here. We have more than 1,000 algorithms published and expected more to come, especially more improvements. It is very easy to generate on scale, regardless quality, but it is complex to generate quality data on scale. So mandatory requirements, data quality, but on the other hand side, the situations we have no intercomparability of all these different data sets and providers that we have nowadays. We have no common quality levels defined, no quality drivers and quality pushers. I think that's a situation where we see that some clients are disorientated and there's a risk of dilution in this situation where actually the market can really grow. So the question is how we can push intercomparability standards and accuracy in the market and with this user uptake and product fitness. So we see different ways in these times. So on one hand side, there's a certain swamping with data products, regardless consistency in standards and regardless market push principles. So there's maybe a lack of orientation considering the role of the institutions when it comes to the tendering processes and up to market distortion even. But we see also very good mechanisms where we can collaborate fostering quality and the quality push independent product standards towards the long-term comparability. I believe that there's an important role for space agencies to support industry standards here, to support product standards for water quality from space, because we have objective and intrinsic quality and sensitivity measures already available, as we can relate basic parameters such as chlorophyll directly to absorption spectra or turbidity to scattering spectra, so it is not so difficult. Still, it is missing. If we have it, we have independent on the method which we apply nowadays or in futures, on the variety of the methods that are provided and on the variety of sensors which we have in the past and in the future, then we have a standard and data comparability. Related studies, I think, are very welcome and needed, as well as user capacity building, and we hope here for a common effort of the community together with space agencies and research institutions. Studies on improving intrinsic detection limits make sense, detection ranges, applicability ranges, and so on. So welcome to keep in touch with this topic. Bye.